discussing that the IPv4. Now, this IPv4 addressing of the logical addressing, and IPv4 is the 32-bit. IPv4 is the 32-bit address. Okay. Now the two device on the internet, can never have the same address at the same time. This is also applicable, that the two device on the internet, the two devices that are present in the internet can never have the same address of the same time. Now, why it should be said that all the two devices that can be present cannot have the same address of the same time? Now, let's say through an example, we understand. Let's say this is a device present and this is also a device present. And let's say there is a packet. So in same time, let's say this is a system present and this is another system present. Now this system has an IP address 128.1.1 and .1. Let's say this system has an like this IP address, and another system that is present, this has also the same IP address, that is 128.1.1. So these two systems has the same IP address. Okay. Now let's say this packet has to be transmitted. Now this packet has the destination address 128.1.1.1. Now, in which system the packet should be transmitted? Because both the systems have same IP address. That means the destination address of this packet is 128.1.1.1. Now this packet will be transmitted to where? Because its destination address is 120.1.1.1 and two systems are present. So that means the ambiguity will be created. Through whom it should be transmitted? Through whom? Through which system? It will take this packet, the system which will take this packet, because both has same IP address. So that's why it is said that the two devices on the internet can never have the same address. Now you can say same address at the same time. Two devices on the internet can never have the same address of the same time. So you can say that let's say so if it is said that if we have n bits, let's two devices on the internet can never have the same address. That's why it is said, because where the packet should be transmitted, it is not possible that the packet will be transmitted both of them, because both of have the same IP address. It is not possible. So that's why what we have to do. So in the same time, it is said that if the system have the same IP address and it is stopped or it is off, then possible, because the packet will be transmitted into this system. But in the same time, it is not possible that both the system have the same IP address, because it will create the ambiguity or it will create the confusion. That is, it is said It is very much important that the two devices on the internet can never have the same address of the same time. Now, let's say if so that's why it is said now the address space concept. The address space is what? It is the total number of address used by the protocol. Address space is what? The total number of address used by the protocol. So that means if we have n bits in the address, then the total number of address generated is 2 to the power n address. This is the concept that if we have n bits of address, that in the address if n bits is present, then the total number of address generated will be 2 to the power. If there is n bits present in the address, then the total number of address generated will be 2 to the power n. So IPv4 is what? IPv4 is 32-bit address. That means in case of n, we can use the 32-bit. So 32-bit means what? Total number of address generated in the IPv4 will be 2 to the power 32. The total number of address generated in the IPv4 will be 2 to the power 32. So that means 2 to the power 32 means total number of address space will be 2 to the power 32, and its value for 42 1 2 3 4 5 6 7 8 9 10. So this total amount value of the device, that means this total number of device, we can provide the address of IP address. That means 3 4 5 6 7 8 9 10. So that means 42 crore 94 lakhs 90 like this total number of devices total number of devices, we can provide IP address, IPv4 address we can provide for this. So this is of the our total IPv4 addressing. Now for IPv4 addressing, some notations are also present. For IPv4 addressing, the notations are present. So what are the notations? Though there are three types of notations present. That is binary notation, dotted decimal notation, and hexadecimal notation. These three notations present. Now in this IPv4 is displayed as the 32 bits or the 4 bytes. IPv4 is displayed as the 32 bits or 4 bytes. So that means what? 32 bits. 32 bits means we already know that 8 bits of 1 byte equal to 8 bits. 1 byte equal to 8 bits. So that's why you can see 0, 1, 1, 1, then 0, 1, 0, 1, 1, 0, 0, 1, 0, 1, then 1, 0, 1, 0, 0, 0. So here, this is of total 8 bits. Then this is another 1, 2, 3, 4, 5, 6, 7, 8. This is another 8 bits. Then 3, 4, 5, 6, 7, 8. So this is another 8 bits. And this is another 8 bits. So this is the concept of the binary notation. This is the concept of the binary notation. So in this what? In this IPv4 is displayed as the 32 bits. Displayed as the 32 bits or the 4 byte. Like this binary notation. Now in the dotted notation, dotted decimal notation. In dotted decimal notation is used to make the IPv4 more compact and easier to read. Now here the binary notation are present. So the binary notation, if we convert this binary notation into the decimal, then the IPv4 will be more compact and easier to read. The IPv4 will be more compact and it will be easier to read. So let's say this type of given, this type it is given. So 100000000. That means it is divided. One by one, we are dividing it. So this is what? 128. Then this binary is 11. Then this is 3 and this is 31. So 128.1.11.3.31. So it is, if you see now, if we look this and if we look this, then it is more